We're going to do a little bit of block universe again, time travel, but time dilation and, stretching of time. We stretch this thing we call time. Mathematicians love to deal with time because they can do whatever they want with time in their equations. And the funny part about it is, where you can start is that they never define the word time. They still don't have an idea what the word time means, right? What the definition of time is. They cannot define it. But here everybody uses it, puts it in the equations, and then gives you, what's worse, a physical interpretation. See, they can do whatever they want in their equations. That's a description. But when they jump the fence and come into physics and try to give you a physical interpretation of their equation, that's where we have a problem, because these people say they are physicists, which they are not. They are mathematicians. But then they give you a physical interpretation, which belongs strictly to physics. They say it doesn't. They say that physics is about equations. And if that's the case, then why did they even attempt to give a physical interpretation? I mean, if it's not part of their job description, if it's not part of their, their job functions, why have they tried to give you a physical interpretation? They're not experts at physical interpretations. And so why did they do that? Well, I'll tell you why. Because if they didn't, their equations are totally meaningless, worthless. If you cannot relate your equation to the real world and tell me how the world works, with or without your equation is worthless. And that's where we stand today. They give you an irrational explanation. When you criticize them and say, look, I call your bluff. Time does not dilate. You cannot travel through time. And you tell them all this stuff. There is no such thing as a block universe. They say, well, that's not part of what we do. What we do is equations. Then why did you attempt to do it? Why did you give me this bogus, explanation of how the universe works? The mechanism, the explanation, when you're not an expert at it, when you later on dismiss it as saying, well, it's not part of our job description anyways. So why did you try? And this is the problem. They sell it to you like if they know, they sell it to you on the basis of authority, and then they take it back when you call their bluff. Okay? And here, we did a little bit of this the other day. I'm going to go quickly through a little review here. We have good old Brian Greene there, Brain Green. And what does Brain Green do? He jumps into a wormhole and he ends up early in the morning where he meets himself. So he traveled through time from evening or noon to morning, and he gets to see himself. So he says you can do this easily by just jumping into a wormhole. Such a cinch, no problem at all. Okay, so this is not the only, just in case, you say, well, maybe he was just talking out of hand or whatever. No, he rubbed it in his, I can't remember, this was from The Elegant Universe or another bit of another series that he had. This is another thing that he showed in that series. And here, let me show it to you. Here goes, watch carefully. He meets the girl, that meets him at the airport or the jet port or the spaceport, and he takes off, goes into outer space, and travels to a black hole. He's going to go around the black hole there and turn a corner and come right back. Okay, so he comes back. Okay, and when he comes back, he arrives here at to meet the same girl, and she's a little older now, And so the question is this possible? Does this make any sense? That he just traveled and, to a black hole and comes back and sees the same girl, but she's not a girl anymore. She's an old lady, but he remains the same. He hasn't changed a bit. Does that make any sense? And they say, well, it makes sense in a block universe that you can travel through time because, you can travel forward. And like in this case, he traveled to the future, right? I don't care how you explain that. It doesn't matter to me. What his mathematics is irrelevant to me. I'm just saying that he traveled to the future. That's what he claims. And he says that's possible. NASA says it's possible. CERN says it's possible. All mathematicians on Earth say it's possible. Okay, so we have this travel to the future. It's possible, right? And I showed this the other day. Here, let me show you this. Give me a second here. And it's this skater. And this fellow is going to, someone's filming him. And this is how it looks. Okay, here it goes. The guy skates. Okay, normal. And now you can see what's happening to all these we'll call him Joe, to all these Joes. Okay, so Joe, we have all these pictures of him little by little, right? And here you see the whole sequence. Okay, so is this possible? I mean, what's the problem here? Well, the problem here is that you see the guy at A, right, which is Joe at A, and the same guy, Joe at B. Okay, that's what the problem is. And why is it a problem? Well, because they say that all these Joes exist simultaneously in the block universe. Okay, so the block universe, you're not seeing time. What you're seeing is a still image, but everybody coexists at the same time, past, present, and future. That's what the block universe is. And the only way you can produce that is if there is no motion whatsoever. First of all, because it's a block universe that you can see in one shot only. That's the first issue. The other one is that there can't be any motion because what they're saying is they're creating matter. They're creating matter. They're creating new Joes at every location there. So Joe from A is not moving all the way to B. What's happening is new Joes are being created in between. And so there is no motion. And they all exist at the same time. So that if you could travel, because I don't know how you can travel in a block universe, it's made of a single piece, right? But let's assume you could travel, you're the only guy who can move. You move and you can see any of those frames because they're still there. That's why you can see them there. You can shake hands with any of those guys because they're still there. The atoms are still there. That's what they're saying. And the only way you can have that is that if you created all these new atoms of Joe that make up Joe. Okay, so this is the big problem that we have there. Okay, so here we have good old Brain Green. And this is what he proposed. He says this is the block universe. Okay, and all those lines that you see there, the white lines coming down, those are slices of time. But we have a problem with slices of time because time is not a slice. They try to say it's a thin slice. No, it's not a thin slice. It's a slice that has no thickness at all. It's zero thin, or zero width, zero length, whatever. It has no width at all whatsoever, that slice. It's a cross-section of time. It's a cross-section of motion. Each one of those lines there represents location. Each one of those slices represents location. It's a static concept. And they say, well, that's time. And that's where the first problem comes in, because time requires at least 2 frames of the movie, right, of the universal movie. And here they're talking about a single slice, which is a single frame of the universal movie. And that's where we start with problems, okay? So what is the problem? The problem is this. Let me show you here, which I showed you the other day. Here we have atoms, and you would think that if you film these 5 atoms, these are the 5 atoms in the universe, just taking it random, and you can see they're moving in the frame, within the frame, right? So you say, okay, they're moving, right? If I were to run this in a movie camera, some kind, you would see the atoms moving from left to right, okay? And they're moving ever more towards the right. Okay, but that's not what these people say in the black universe. What they're saying is that they're creating matter. They're creating these atoms. They're duplicating each one of those atoms. What you're really seeing is this. You're seeing that each atom is being reproduced. Actually, not even from frame to frame like I'm showing there. I just illustrated so that you can see what these people are saying. They're saying that the previous atom never moved. It's always there. And the only frame that really exists is frame number 457. In fact, someone asked the question, says, well, here, you see that all these other frames, they're just imaginary. You know, they don't exist according to the block universe. The block universe only includes that last frame, 457, and that's the only frame for the block universe. Okay? And so if we were to put the skater now, you'll see that, you know, all these other frames that were there, they're not really there. According to the block universe, the only frame that exists is the one at 457 there on the right. That's what they're saying. And they're saying that all these atoms were created, instead of having there be any motion, no, we created all these atoms of Joe, and he's in the entire picture. In other words, the block universe is a photograph. It's not a dynamic concept, okay? So I hope you're understanding what I'm saying here, okay? Okay, so where does this all lead? Well, here, all these frames exist, okay? And there you see frame number 457. That's the present. We'll call that the present. And that's you there. And we have an atom in your shoulder, that red one there, kind of big, right? But just illustrating there. And the question is, can you travel to frame 154 and talk to yourself? Can that atom be at two places at once? Can it be at frame 457 and also at frame 154? That's the question we're asking, right? And one fellow asked that question. In fact, he said the following. He said that frame 154, he says, here it is, says, that frame 154 exists only in memory, right? And that's true. It only exists in your memory. You know, sometimes you film it and you say, what's in the film? Yeah, it's in the film, but the film is in the present. So it's not like you're looking at the past. You're looking at something that was kept in memory, in some kind of memory. It could be a device, could be your brain, you know, but it's kept in memory, but it doesn't exist out there for real. That atom is already gone because it's now at a different location. That's what it is, okay? So yeah, frame number 154 does not exist. There's nothing there, okay? And so here it is. You know, frame 154 does not exist. What exists is only what is in frame 457, the present, okay? And all the other frames, both before and after, the future as well, they don't exist. They're not there. Why? Because that frame 457 only it has location, existence. And if you remember, you know, from the Universal movie, existence and location are static concepts. You do not need to move in order to exist. You do not need to move in order to have location. Location is a static concept, so is existence. What is existence? An object with location. And that is in a single frame. That's what we call existence. People who don't like the definition have a very easy task. All they have to do is define the word existence, and then we'll know what they're talking about. Until then, you know, you have to accept the definition, the scientific definition that we propose here. Okay, so here we go with this. Fellow says, travel dilates time, he says. Travel dilates time. They're talking in these terms. They say it dilates time. They see time bending. It's dilating, I guess, getting bigger or whatever. 5 years on a ship traveling at 99% the speed of light, 2.5 years out and 2.5 years back, corresponds to roughly 36 years on Earth. 5 years in space equal 36 years on Earth. Okay, that's what he says. This is what they talk about. And the answer is no, first of all. It's absolutely not true, you know, and this is very easily shown. I don't care where you go. You can go into a black hole and come back. If you want, you can go through a wormhole to another universe and come back. We don't care. The year is defined as one revolution of the Earth around the sun, okay? So the Earth went around the sun either 5 times or 36 times when the guy gets back. So he can't have it both ways. Either the Earth went around the sun 5 times or it went around the sun 36 times. One of the two persons is wrong. And they say, well, I took my atomic clock with me and I measured time with, you know, precise seconds. Well, first of all, there are no such thing as precise seconds, and we've shown that with GPS because clocks run a little differently up there than they do down here. So I don't care how accurate your atomic clock is. As soon as you travel outside the Earth, going to space, well, all bets are off. Your clock is going to tick at a different rate. So we don't know what it's ticking. But again, we don't define the year counting seconds on an atomic clock. The way we define the word year, so we know whether you are 40 years old or 45 years old or 50 years old, you know, how many candles we put on your cake. The way we do it is by revolutions of the Earth around the sun. And again, either that's the best clock there is for the word year. Okay, and so the Earth went around the sun either 5 times or 36 times. One of the two guys is wrong, and hopefully it's the guy who traveled. Okay, so we don't care what that guy measured. When he comes back to Earth, he better have the same number of revolutions around the sun as the guy that was on Earth. Okay? Can't be both ways. That's the way we measure time. We don't use these fancy clocks that the mathematicians use to confuse themselves. Okay, so here we have good old Brian again, and let's put him on again. Here he goes. He's going to travel through that black hole, okay? And when he goes out there, and then he comes back. Well, we'll wait for him to come back. Okay, that's 2.5 years, right? Round trip, 5 years, right? Goes around the black hole, comes back, and gets to see the girl again, okay? No longer a girl, okay? And now he's back on Earth, and he sees what? He's going to see this old lady, and that was the same girl that he loved. Now, the strange thing for me about this is that, I was surprised that they still had check-in agents in the future, you know, so many years into the future. You would think that in the next 20 years, they won't have any check-in agents at the airport anymore. But that was, surrealistic for me. But okay, what is good old Brain Green saying? You know, here it is. He's saying that he goes from slice A to slice B sometime into the future. He stays the same. You can see he hasn't changed much. But the girl, man, boy, she suffered quite a bit. Time really was, very harsh on her. Okay, and so we have a problem with this because you're saying, okay, is this true? Does this make any sense that he stayed the same and she changed? So we're not only talking about time travel here, we're talking about physical, biological changes. Have we really changed? Do we really think that someone changes biologically in this sense, that just because they travel outside the Earth and come back? Okay, I mean, you could say that his clock went wrong, you know, that his atomic clock had measured wrong because it was in outer space moving around, etc. Does that mean the guy is physically different, or that affects him physically, like biologically, to such an extent that he remains more or less the same, you know, very little change in his appearance, whereas the persons on Earth aged, 40, 50 years more than he did, and so, again, no common sense there. And of course, when you point that out to the mathematicians, they say, well, that's philosophy of science anyway. We don't care about that. Well, then why did you try to convince me of it? Why did you try to sell me this bluff, and when I call your cards, you don't know what to put on the table because you don't have an answer, a rational answer. Okay, so how do we tackle this problem about time dilation and time travel and stretching time and playing around with the word time? Well, the first way you can do this, the best way, the first step, is to find the definition of the word time. I mean, what are we talking about? What is time? What is this thingy we call time, And so here's a fellow, and he went out there and he looked at a couple dictionaries, and he puts this. He says, from Cambridge, time is what we measure in minutes, hours, days, etc. Okay, it's what we measure. Okay, great. Whatever that is, Oxford, what is measured in minutes, hours, days. Longman, the thing that is measured in minutes, hours, days, years, etc. Okay, and Britannica, the thing that is measured as seconds, minutes, etc. So they all say the same thing. It's measuring of seconds, minutes, hours, years, whatever that is. I mean, what is that? What do you mean you measured Hours. What does that mean? What did you measure? Hours? What is that? I thought hours is defined as time. How are you going to define hour except using the word time? And if you define the word time using the word hours or minutes or second, you're just running around in circles. Okay? So let's go to a more, because that came out, I guess, primarily from Google. The guy just searched Google and found those. Fine, no problem. Those are the dictionaries, what the dictionaries say. Here, let's go to an official site. Here's the NIST. NIST is the National Institute of Standards. Okay, and this is a fellow who's worked many years, 37 years working on developing atomic clocks of the future. Has been the focus of my career over the past 30 years. Okay, so he tries to answer, what then is time? Okay, so here we have an expert. Okay, fortunately, finally. Time appears to be the most bizarre of our basic units. Time is a slippery creature. Now, that's a terrible way to start a presentation, right? St. Augustine remarked, what then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. Okay, that's great. So St. Augustine had no idea what time was. How about Heine? Well, Heine says, concluded after much thought that time is what clocks measure, which was what time, seconds, minutes, hours, years, right? Okay, so we haven't learned much from Einstein either, okay? And then he continues, says, whatever time is, for reasons for which I still puzzle, so he still doesn't know what time is, we can measure the passage of time precisely. So all he does is measurement, but he still has no idea what time is. He cannot define the word time, and he just measures it, whatever that is, whatever he's measuring. And he says, time is the accumulation of identical, repeatable events. I guess that's when you see Joe in every frame. Repeatable, right? Time might be the ultimate motion. In other words, he has no clue. Here's a guy who studied it for 30 years. He has no idea what he's measuring. He has no idea what time is. And this guy's at NIST. He's got a PhD, etc. So the question is, here you have these gurus. They talk about time, and they have no idea what time is. And so here we have one of our fellows here. His name is Matt O'Dowd. Okay, and he works for PBS. He does this program called Space Time. And he's going to tell us everything about time that you always wanted to know, you were afraid to ask. Okay, and so here it is. And he starts his presentation a little bit on the wrong foot. Okay, so here it is. He starts out, and he's really a caricature of a physicist. He's really a mathematical physicist. He doesn't know anything about physics. And here you can see it. We're going to start out by me totally convincing you. Oh, so his job is not to explain something to you in a rational manner. He's here as a prosecutor trying to convince you of something. Okay, so his job is not to explain or say something rational. He's just trying to convince you. Great. Sounds like religion to me. That time must run slow in a gravitational field. Mass and energy change the lengths of rulers and the speeds of clocks. Mass and energy, two concepts, and they change speeds of clocks. I wonder how mass and energy do it. I mean, these are concepts. I mean, how does a kilogram, right, mass, how does a kilogram change the speed of a clock? I mean, does it smash it or what? It says the curvature in the fabric of space is the cause of gravitation. So he says curvature of the fabric of space. Well, space is not a fabric. Space is nothing. Space is the same thing as vacuum, as nothing. They're synonyms. Nothing means it has no shape. Okay? No dimensions, no volume, no radius, no diameter, no nothing. That's what space is, nothing. And so how can you have the curvature of nothing? But he says that's what causes gravitation, okay? Over the course of your life, your feet will age 1 second more than your head due to gravitational time dilation. Okay, so your feet are older than your head. This is what this, we call them scientists. What do you call this guy? Well, we call them idiots. And you say, Bill, you're insulting the guy. And no, I'm not. I'm treating him with the respect that he deserves. If this guy studied 10 years at the university to come and tell you that your feet are older than your head, he's got to be, if he really believes that, he's got to go to a psychiatrist. In other ways, he should be laughed off the stage. Okay, that's how simple it is. You're held in your chair right now by the curvature of time. The curvature of time? What is this being brain talking about? What do you mean, how can time curve? What is he talking about? You're held down because your butt is ticking faster than your head. And yeah, I didn't invent this. This comes out of his video. Okay, this is how he starts his presentation. Okay, so not a very good way to start a conversation. Scientific presentation, scientific dissertation, saying that your butt is glued to your chair because time is curved. What does that even mean? What is he talking about? And again, when they dismiss and say, well, that's philosophy. No. Why did you even try to convince me? That's just what he was trying to do. He was trying to convince us, right? He's trying to persuade, convince, recruit us, telling us that he knows, he's an authority. And this is what he comes up with. Okay, let's see. Let's see how it continues. Then he goes out and he says, is all that exists now whatever exists right now? The answer lies between the past and the future, in the elusive, ever-moving eye blink that we call the present. Well, it's not an ever-moving because the present is not anything that's moving. So we need to find out what the present is. Okay, and until he can define the present, he cannot say it's moving time or the moving present. Okay, the present doesn't move. Okay? And if we're talking about now, the present, we got to define. We got to have an idea of what this present, this now means. Otherwise, we don't know what he's talking about. He can just give us all this verbiage, and we have no idea what he's talking about. Okay, so here he goes. He says, Newton's picture of the universe included one assumption that we know for sure is wrong. Okay, what is that? The idea of an absolute, clearly definable now. In other words, he's saying you cannot define the word now. You cannot define the word present. That's what he's saying. Okay, and he says Newton failed because, we know that there's no way that you can define the word now. That's how he starts. Okay, so he says, Newton assumed that all particles, all observers, all points in space were ruled by a single constantly ticking clock. This universal clock meant that it was possible to define a notion of now that everyone would agree on. Well, we don't care about agreement. In science, we do not agree. One thing is to define it so that it can be used consistently, rationally, in other words, in an objective manner. And he who doesn't like the definition or has a better one, comes up with a better mousetrap. Or keep your trap shut. Okay, just like that. It's very simple. This is not a question of agreeing. This is a question of defining in such a way that you can use the word consistently, that we know what the word now means or the word present means. Okay, so we look up the word now or present, and this is what we find out there. Oxford, Wikipedia, and Merriam-Webster dictionaries, right? The present, the period of time now occurring. Okay, what is now? Now at the present time or moment. So now is the present now. Great, we've learned a lot. We have these synonyms there, right? Wiki says the period of time that is occurring now. What is now? The present time. And Merriam-Webster, now existing or in progress. What is now? At the present time or moment. So all they did was run around in circles. We have no definition of now or present. And so Mr. O'Dowd was right in that sense. Nobody in mathematics, the religion of mathematics, mathematical physics, people who studied for 10 years and got a PhD, not one of them can tell you what the word now or the word present or the word time mean. They have no idea. So they start talking about them. They tell you all these great things about now and the present and time, and not one of them have been able to define those three words in the last 100 years. Okay, really in the last 10,000 years. Okay, how does this fellow continue? Here he goes. He says, we only experience a single slice at a time, the one that currently exists. Okay, so we have a contradiction there because he says single slice at a time, and he's saying that it's the only one that exists. Exist is a static concept. You don't need to move to exist. He says it's a single slice of time, but time requires two frames. So he's got a contradiction. Either the single slice exists or it's moving through time, as they say. It takes up Either it takes up one frame in the word exist, or it takes up two or more frames in the word time. It can't be both. And there he starts with that contradiction. He doesn't even understand what he said there, right? Or his contradiction, the paradox that he's created there. But then he continues, he says, we can imagine a perspective from outside of both space and time in which this entire structure just exists. Okay, so he's saying that it's a structure, meaning this whole, what he's going to call the block universe, exists in a single structure. Well, then he's not talking about time. He's saying there is no such thing as time in this structure. Okay, it just exists, which is correct. I mean, if he's going to talk about the block universe, it just exists. There is no such thing as time. So he cannot later divide it like Brain Green did by cutting it into slices of time. No, those are slices of locations, if anything, right? But not of time. From that perspective, time does not have a particular direction and there's no preferred present. Well, we don't know about preferred. That's an irrelevant term. We don't care if it's preferred or not preferred, if it's good or bad. Those are qualifiers that we do not use in science. Time is just a dimension like space, and we only observe the flow of time. Now he's talking about the flow of time, and then he talks about existence of time. So either it flows or it exists. If we play these slices in sequence like a flip book, okay, well, he can't do that because he's saying that it's a single block. And we use the term block universe to refer to this view of all space and time just existing in this four-dimensional chunk. So we have a problem because they're mixing dynamic concepts such as flow, right, that something is moving, with an existing chunk that you can see in one shot. So either we're talking about something in motion or we're talking about something that is static. And they don't realize their contradiction. They just use these terms because, again, they never define the word time, the word present, the word now. They don't define these terms. They just use them. They say, oh, you know. And yeah, so they have this block universe, a single block right in front of you. You can see the whole block, but they talk about time moving through that block. Well, if it's a single block, then what you're doing is putting a movie within a picture, which is totally irrational. You're saying that, the Mona Lisa is smiling within the picture. But for smile is a verb. You need at least 2 frames of the movie. I mean, if you have the movie of Mona Lisa smiling, you can see her face changing, her mouth changing, her eyes changing. But you can't see that in a photograph. And these people are saying that Mona Lisa smiles within the photograph. They're saying that the block universe exists within a single photograph in which time is moving. So we have a problem there, serious problem with that. So what's he talking about? Well, he's talking about something like this, okay, where God looks at the block universe there, right? Those white lines coming down, up and down, those are time slices, as they call them. They're really location slices. And, God can see them from heaven, I guess. You can see the whole block universe in one shot. Well, if you can see it all in one shot, then those lines there cannot be slices that are moving across the screen, because either we have a static image or we have something in motion. If I want to see that in motion, I need many frames of the film. I cannot see it in a single frame as you see there. Okay? So this is where the contradiction lies. Okay? And he continues. He says the following. This is how he's coming up with all this stuff. He says, to us, none of the rest of the block universe exists because our existence emerges from the forward evolution of a razor-thin slice. So he kind of defining existence there. He's saying that it's an emergent property that has to do with a forward evolution of a razor-thin slice. That's more or less how he defines existence. He's defining existence with motion. He's embodying motion into the word existence, okay? So he's saying existence is an object that moves, and we say existence is an object that has location. Existence is a static concept, not a dynamic one. It says the perception of existing in a single instant in time is definitely an illusion. Well, that is the definition of existing. Existing means that you exist in a single frame of the universal movie. But this guy says it's time, and time requires 2 frames. Okay, so you exist in 2 frames. So when you say that I exist, what he's saying is that you're in 2 frames at once. You're in frame 457, was it, and 458. You're in both frames because in order to exist, you have to move from one frame to the other. That's what he's saying. In his special relativity theory of relativity, Einstein showed that there is no absolute way to define whether two events happen simultaneously. How do we even say that now, what now means for other parts of the universe? So he says we cannot define this word now. Why? Because it takes time, right, or motion for an image from that other side of the universe to reach your eyes. So he's saying, did that happen at the same time that I'm staring at it? But that's not the issue. The issue is, the question is the word now and the word present and the word time. And again, he hasn't defined them. But if we talk about now, what are we talking about? Okay, that's what we got to figure out, what the word now and the word present mean. What is the scientific definition of now? What is the scientific definition of present? So that we can use it consistently in a conversation. This guy is all over the place. He's talking about meaning motion, observer. You have to wait for the image to reach you, and then you don't know if it happened now or it happened before or later or whatever. And then he hasn't defined present or time either, right? Nothing, not even information, can travel faster than light. We don't care about that, even though it's true. Yeah, that means that any distant event is already in the past by the time we see it. Irrelevant, totally irrelevant. We're talking about now and not now when it happened. Okay, either we talk about now, present, or we talk about happening. Happening requires two frames. Now and present, single frame. They're static concepts. The present, the now, is right now, one frame of the film. Okay, so here it is. This is from good old Brain Green again, and he's saying that you have all these time slices in the universal block universe, right? And yeah, again, we have a problem because you can see we need a movie to see all these time slices and how they're coming up one after another. And that's not what he showed. He says that you can see this whole thing in a single picture. And so we have a contradiction between what they illustrate and what they're saying. They're saying you can see it all in one picture, and here you see many pictures. You see many frames. Okay? So they do have a contradiction. Okay, so why don't we define this famous word time and not so much time, but present and now. What are the scientific definitions of these words? And here it is, okay? Here's the scientific version, okay? Present, now, it's a static concept, okay? And they involved only location. Location is a static concept. It also involves existence. Existence is a static concept. You don't need to move to exist. Okay, so what's the present? Location of every atom in the universe, okay? Single frame of the universal movie. So in one frame, the yellow concepts there, they're all static concepts. You have object, distance, location, existence, and we can add now, present and now. That's what present now mean. Whatever's in that picture in a single frame, that's now. And it only involves location between atoms in the universe. They're not what you see on the bottom there. Time is a dynamic concept. In order to conceptualize time, you need at least two frames of the movie. Therefore, now is not part of time. Okay? Now is just a single frame in the movie. Okay? Time, on the other hand, first you require motion. You can't have time without motion, and time is simply a comparison of two motions. Okay? So and you require memory. Okay, so what are the conclusions from Mr. O'Dowd? He says, consider the time slice of your present. Okay, we're in the present. It's a time slice. So hopefully there's nothing moving in that present, right? We can imagine other observers on that time slice that surely must exist. Again, he's talking a single slice, meaning nothing's moving really, because he's talking about time, but really he's talking about location. Okay? And he says nothing's moving. You have observers on that same slice, which is a slice of location in the universe. Every atom just has distance with respect to all other atoms in the universe. That's all we have. It's hard to accept that only the present exists, which is what he just defined. In other words, what we're talking about is location. That is the present. Okay? That only the current slice of the black universe has meaningful reality because it is impossible to define what that slice actually is. What do you mean it's impossible? I just defined it. I'm saying it's location. It's location of every atom in the universe. That's your slice of what he called time, which is really a slice of motion, location. That's what that is. It's just location. It's also hard to accept that only the past exists and the future doesn't, because the present of someone else on your slice of present could be literally any point in your future. Absolutely not, because now he's talking about motion. He's saying, I'm going to move to the future, right? And I'm going to meet this guy that took me time, took me motion to get there, right? And so he's saying it took me motion. By the time I get there, well, time has passed. And now we're talking about his now, my now, everybody's now, his present, my present, so they get all mixed up with all this stuff. No, it's very simple. All you have to do is cut a slice and find out what's in that slice. In other words, what is in a single frame of the universal movie? You got to stop the universe. Then you'll know what now is, and you'll know what present is. And what it is one atom located with respect to all other atoms in the universe. And hopefully, unlike they said with time travel, that atom cannot move to the past and find itself in another frame, because that means that you're creating atoms all along. For every frame, you're creating new atoms. You're not moving. You're really static in the block universe, and all you did was, because you were able to move somehow, you were able to go and see that same atom at a different location inside the block universe. And again, all that's irrational. But that takes 10 years at the university, getting a PhD, really at a monastery, and then you'll understand it. Until you do, you'll never understand it. Yeah, it's called brainwashing. Or what he said, what Dowd said at the beginning, I'm here to convince you.